Okay, you should have your packets that you were given, and we're going to skip through some things and just work on our logarithmic functions. All right, in the previous section, we did exponential functions. Remember, they are with x in the exponent. That's what exponential means, okay? X in the exponent. Okay. So does f of x pass the horizontal line test? Now, this is kind of thrown at you, but you know what vertical line test means. That means if you graph it. So let's just graph like any exponential function. Okay. There's a growth one, and then here's a decay one. Okay. And if we think about the vertical line test, it definitely passes it. Yeah? Well, what about the horizontal line test? Well, if you draw horizontal lines through it, it passes it. Now, this looks kind of questionable, but that's because I can't do that Zeno's paradox thing where I get closer and closer and closer to it. That doesn't mean that it actually is a flat line. It gets closer and closer. If I zoomed in, it would still be going down. And then if I zoomed in some more, it would still be going down. So every time you zoom in, it still is going down. So each one of those passes the horizontal line test. So the whole thing passes the horizontal line test. Now, why do we care if it passes the horizontal line test? Well, what this means is that the function has an inverse. The reason why it has to pass the horizontal line test is because when you invert a function, that means you switch your x's and y's. Well, if you switch your x's and y's, then the new function would not pass the vertical line test if the old one didn't pass the horizontal line test. Okay? So, in other words, horizontal line test is that, let's see, so need to pass the horizontal line test so that when we find the inverse, which inverse just means switch x's and y's, the inverse is a function. And a function means VLT, right? Okay, so that's all that I just said in a nutshell. The equation defining the inverse of a function, well, the equation defining the inverse of a function is found by, I just said it right here, I jumped the gun, as usual. It's found by switching the x's and the y's. Let y equal a to the x. That's an exponential. Then its inverse equation is, give me a second. Okay, it's x equals a to the y. However, we do not like to write functions in terms of y, but in terms of x. In other words, we don't like this. This is right here. We do not like an input y. Okay? So that means that we need to resolve this thing for y. All right? And that's where the logarithm comes in. All right? So the definition of logarithm is just that it's a way to solve an exponent, to get an exponent out of the exponent. Okay? That is literally what it is. It is the way to get an exponent out of the exponent. Okay, so if you're asked what the logarithm is, it is literally just the inverse of an exponent. Okay, so it's just the inverse function of an exponential function. Okay, and what it does is it removes the base. Okay, so this is something that students get confused because they go, well, wait a minute, I know that in germ DOS, what does this say right here? Well, that says that exponents and radicals, or roots, are inverses. So if exponents and radicals are inverses, then how can exponents and logarithms be inverses? They are different things. They do different things. To get rid of an exponent, you use a radical. What do I use a logarithm for? To get rid of a base. So that's not even in our germ DOS. It's like to break into an exponent, to hack into the exponent. Like here, if I wanted to get to this exponent and I wanted to get rid of the base 2, then I would use a logarithm to break into that exponent. Okay? Okay, so let's summarize. Okay? So exponents are removed using radicals. Bases are removed using logarithms. Okay? All right. So I just have this little bit of space here so that you could see, like, just kind of practice it a couple of times. So if I start with a to the, let's do another one. If I start with, oh no, I have practice down here, so let's just go ahead and skip down to here. Okay. Oh, I know what this is for. So this is just to help you remember. So like notice here that the base of the log, this is log base A of x. That's how you read this. Log base A of x. Okay, notice that the base stays the base. So base stays. But notice here, the exponent is now alone. And the output is the input. The input is the output. Right? That's what inverses do. Input becomes output. Output becomes input. Okay. All right, so convert to exponential form and solve. So really, if you see a logarithm, if it ends up being nice numbers, it is easier to solve. Exponential form is easier because you've been working with it longer. You understand exponents. Excuse me, you understand exponents. You are just now learning about logarithms. It's like this whole new thing. So if you're not sure what to do with a log, just convert it to exponential form and then try again, okay? All right, so, but I want you to try not to look up here, and I want you to try this without looking, okay? So just give it a pause and try this one, and then I'll go. All right, so I want to convert this to exponential. The base stays the base. So I'm just going to go ahead and write that. Then the output becomes the input. And the input, this is the input, becomes the output. Not so bad. You just got to kind of walk yourself through it. So give yourself some notes right here. Base to base. Right? Oh, and I already did this. So maybe I should just move that over there. Base stays. There you go. All right. Now just think 3 to the what equals 9? Oh, well, 2 must be 2. Done. Okay. All right. Now try the other 2 and see how you do. And then after you unpause it, so pause it, try those 2, then unpause it and check how you did. All right, so base stays base, output becomes the input, and the input becomes the output. All right, so what cubed equals 827? Now, this is an exponent, so you could take the cube root of both sides, or you can just think. What cubed makes 8? 2. What cubed makes 27? 3. There's my answer. All right, and then pause and try. All right, so then base stays base. Then output becomes the input. Input becomes the output. Now this one's a little tricky. So I want you to think about common bases to solve this one, like we did. I don't have it on here, but like we did a couple of pages ago in your packet in 4.2, the page 7. So look back at page 7, pause this, go back to page 7, and look at like A and B, and see if you can figure out how to do this one. And then, after you've given it a try, then unpause it, and I'll go through it. All right, so this is 7 to the 2x equals 7 to the 1/3. So that must mean, because the bases match, we're just going to logically exclude the bases now and say, well, 2x has to be 1/3. And then I'm going to divide by 2, but don't divide by 2 because you got fractions. Instead, what are we going to do? We're going to multiply by the reciprocal. So multiply by half, multiply by half, so x equals 1/6. All right. Now I'm going to try the other way. Hold on, let me see. Okay. Just kidding. All right, so, graph 2 to the x. Okay. Well, that's from the last section. So if you need to, pause it. Go look, remember how to graph it. Right? But again, you can always pick, plug, plot whenever you're not sure what to do. So -1, and then 0, 1, and then 2. So that's -1 is a half, 0, 1, 1, 2. And then we get, remember, don't forget about your horizontal asymptote. We got to see which way that's going. And it's definitely going that way. And then by 2, we get, I can put that on there too. Okay. So, missed that guy. Okay. Now, let's write what the inverse of f of x is. Now, remember, you can do that. You can do it. Inverse. What does inverse mean? It means switch x's and y's. What is the inverse of an exponential function? Inverse would be a log function, remember? Okay, so this is y right here. This is y. equals 2 to the x. So this is going to be what? Let's try it here. Log base 2. The base stays base. Now, the output becomes the input, and the input becomes the output. Yes? Okay. So, well, now that's the output and the input. Okay. That's how you figure it out with numbers, but now we've actually inverted it. Okay. So the values become inverted, but they're now our new x's and y's. So we're going to make a new xy chart, and we're going to think of this as log. Y equals log base 2 of x. Okay, so yes, the output becomes the input, and the input becomes the output. That's for our values, but we don't ever call the input y and the output x. This is the y value of the original, so of f. And this is the x value of f. But now when we have g, g is a whole new name, so its input is now x. So it's still log base 2 of x. So I know that can be confusing to students because they're like, wait, I thought we switched this x and y. So let me explain that again. This is a new function, and so for the new function, we're going to call its input x. But we know that this x was the original y. So this was the original y. Okay, and this output is the original x. And it's easier to understand if you look at this chart. So that's why I wrote that over here, and then I thought I should talk it through a little more. Okay, so these are going to come over here. See? And these are going to come over here. So what do you think this horizontal asymptote is going to become now for the logarithm? Exactly, it's going to become a vertical asymptote. Okay, so and that's the other thing. So this has a horizontal asymptote, and this one is going to have a vertical asymptote. Okay, don't worry, I know you're a little stressed about this. I can feel it, but you're going to get it. You're totally going to understand it. It just takes a little bit of practice because it's brand new to you. So don't feel stressed out about not getting it immediately. It takes practice. It is a brand new language that you're learning. Languages take time. They take practice. You'll get it. Okay. So let's try graphing these two. These are just basics. That's why I call them parent functions here. These are just basic. Log base 2 of x and log base 1/2 of x. Okay. The easiest way to do this is to actually just go, all right, well, this is y equals log base 2 of x, and turn it into the exponential form. That would be 2 to the y equals x. I should have told you to pause it and try that. Sorry. Base, and then output, input. I kind of like do this loop-de-loop thing in my head, like 2 to the y equals x. And then the log goes away. All right, so I can totally make an XY chart of this, but which one would it be easier to pick? I'm going to pick my y values. So -1, 0, and 1 go over here, which we talked about that over here. The original y's become the inverse x's. Or in other words, the original x's become the inverse y's. Okay, so back to here. They're easy. These are easier to pick this time. Okay, so then now what? That's 1/2, that's 1, and that's 2. So now let's graph these points. 1/2, -1, 1, 0, and 2, 1. Oh, look at that. If you look at it, it looks like It looks just like the exponential but turned sideways. That makes sense because it's actually the x's and y's are just flipped. Keep going if you need to, but remember you pick x's on the, you pick the y's and get the x's. So like 2, right? If I pick 2, I get 4 for my x. So that would be the point 4, 2. Okay. So this must be the vertical asymptote here. And remember, we get close to the vertical asymptote, but never touch it. All right, now let's try this one. Right, this is y. So then we get, all right, pause it and try to convert it. Okay, so 1/2, don't forget the parentheses, to the y equals x. So now I'm going to make an xy chart. -1, 0, 1. All right, so then that's going to be 2, 1, 1/2. 2, -1, 1, 0, 1/2, 1. That's getting closer, so again, my vertical asymptote must be over here. And this is interesting. It falls when, let's see, if I wanted to go 2, what could I get? It'd be a quarter. Oh, wrong. 2. Ooh, that'd be bad. That's a quarter and 2. I don't want to graph that one. What do I need? -2, I guess, huh? -2? Yeah, that would be 4. Here we go. So 1, 2, 3, 4, 1, 2. Okay. All right. If you need to, you can just like rotate the whole thing 180 degrees. Make this the well, not quite, because that's a positive, and you would need to, so it actually has to flip, not rotate 180 degrees. It has to flip along, like, along the line y equals x, because that's what inverses do. So if you were to graph y, let's graph y equals 2 to the x. Okay? So y equals 2 to the x. -1, 1/2, 0, 1, and then 1, 2, and then 2, 4, and then it gets a horizontal axis. And if you're going to graph this on here, you should definitely be using a different color, a pen or something, so that you can tell the difference between which one is the correct graph and which one is for show. Okay, notice they're inverses of each other, and the reason why I chose another color was because then I wanted to show you. So here's the line y equals x. So you don't actually have to memorize anything about logarithms. You can just graph like y equals 2 to the x, and then flip around. See that? See how it flips across the line? See, that's 1, yeah, I'm still right. That is like straight across, hitting a 90-degree angle there. And then straight across, and then straight across. So it's not quite a turnaround. You have to like flip it across the line y equals x. And this makes sense because inverses switch the x's and y's. So where are inverses going to be equal? When y equals x. That is their mirror. Okay? All right. So, and if you want to, you can graph 1/2 to the x equals y and try that one out. And they will, again, be flipped right across the line y equals x. They're not going to flip across this one. It's tempting to go, oh, then that one's going to be here. No, it's across the line y equals x. So this point goes to here. This point goes to there. Okay. All right. Anywho, all right. I don't like this summary thing, I think numbers are better. When you get into pre-cal, you can do it with letters. Okay. So, this one. Now we got to graph this. Well, okay, this is going to get a little bit harder now. So we got, let's write this as y. So we have 3 to the y equals x minus 1, because all that's the input. Remember, base to the output equals the input. Okay, now this is much easier if you just go 3 to the y plus 1 equals x. Okay. Now, which one's easier to pick? The y's. So -1, 0, 1. So then this is interesting. I need to kind of move it over because I need more space for my x's. I always forget that because you're like actually solving for x now. The y's are easy. -1, 0, 1. Try that again. Okay, so this is 1/3 plus 1, which is 1 1/3. So 1 1/3, -1. All right. 3 to the 0 is 1 plus 1 is 2, so 2, 0. And then 3 to the 1 is 3 plus 1 is 4, so 4, 1. 1. Now I got to figure out where that vertical asymptote is. If you're not sure, try plugging in something like 1, okay, for the x value, okay? If you plug in 1, you get log of 0, all right? That does not exist. You can't get, let's try getting -2. Let's plug in -2 for y. We get a 9th plus 1. So we get 1 and a 9th. If you're not sure, just plug in more. Try to get here. So I'm at 1 and a 9th, -2. That's like here. Obviously, my vertical asymptote is now 1 because I can't try -3 to get a y value for -3. Then I get a 27th plus 1. That's 1 and 1/27. So again, 1 and 1/27, itty bitty again. Okay, so clearly my vertical asymptote is at 1. So I was getting ready to tell you like why you couldn't get 0 in the input, and then I decided I would show you more examples of it, like getting there, so you know you don't have to memorize that. But in general, if you set the inside equal to 0, that gives you your vertical asymptote. Just like with denominators, when we set them equal to 0, that gave us our vertical asymptotes. With logarithms, your inside can't ever equal 0. Here's why. Let's go back to here. Ooh, look at that mess. Okay, let's put an inside of 0 in another color. So we have y equals log base a of 0. What does that mean? Now interpret it into exponential form. So that would be a to the y output equals input. You can never raise anything, no exponent makes 0. Because, oh, I shouldn't put an exclamation. It looks like a 0 factorial. Okay, because if you do a negative exponent, it just gets a flip. And if you do a positive exponent, you certainly don't get 0. And anything to the 0 is 1, not 0. So you can never make a 0. So you can never have an input of 0. Okay? All right. And then, oh, and you can't make negative numbers, because negative exponents make positive numbers, and positive exponents make positive numbers, and 0 makes 1 again. So you can't have negative input, okay? So the domain, oops, dyslexic, try it again. Domain which means input, okay, is always greater than 0. Oops, not greater than or equal to, just greater than 0. That means the input, not that the whole thing has to be always greater than 0. If I have x minus 1, then x actually has to be greater than 1. Okay, this one, what is the input of this logarithm? Now it's very clearly got some, what do you call it, parentheses there. So this is just the input. So that means our vertical asymptote is x equals 0. So I can go ahead and put that. All right, now let's turn it into logarithmic form. Y equals, exponential form. Log base 3 of x, okay, minus 1. Now before you can do the base to the output, this is weird. It's on this side, but it's not an input of the log. So I'm going to move it to the output side. Y plus 1 equals log base 3 of x. Now I have an input and I have an output. Okay, so base to the output equals the input. Great. Now I have my x. Give yourself room to actually figure out x's. And then y. -1, 0, 1 works just fine for x's. For y's. So now I get 3 to the 0, which is 1. So I get 1, -1. 1, -1. 3 to the 1 is 3. So I get 3, 0. And 3 to the 2 is 9. So 9, 1. 6, 7, 8. Oop. Still on the graph, so that's good. If it wasn't, then I just wouldn't put it. So it must be going this way. That was hard to draw. But not so hard to find. I think they're actually easier to find than exponentials or radicals or whatever. You just switch them and then pick your whatever y's you want. Don't forget, though, that you need the log all by itself before you convert. So that's kind of what we learned from this one. Well, that's definitely not kind of what we learned from this one. Get the log. Get log alone before you convert. Okay. All right, so I'm going to stop there, and then I'll make a new video on the properties of logarithms, because I would like for you to try some of that graphing logarithms before you move on.